Hello and welcome out there. This is my second video on inequalities, but before we move on to the new stuff, I just want to quickly review what I talked about in the first video. In the first video, we talked about being able to read the greater than or less than sign and being able to translate from the algebra to the graph. So here we've got two quick examples right here to take care of. Let's see. When we read our inequality, we want to look for where the variable is. So here we go. X is greater than or equal to 8. So what this is telling me is that all of the interesting features around our graph are going to happen at 8. So I'm going to mark 8 on our number line. Now I knew it was greater than because the greater than symbol is opening up towards us. I like to think about it as eating the variable. So I know that because it's got the or equals to, it's going to be a closed circle or filled in. And because it's saying x is greater than, that means I'm going to want to shade all of the other numbers which are greater than 8. To be greater than 8, you'd have to be further to the right on the number line, like 9, 10, 11, 12. Alright, let's take a look at the second one. Here we've got the variable on the right side of the inequality, so this is where we're going to start to read. Here we have x is less than negative 2. And I know that it's less than because it's turning its back on us. I'd like to think about it as it's shunning us. So let's see. The interesting part will happen at negative 2. Well, if I'm less than negative 2, that means I can't be negative 2. It's not allowed. So I'm going to leave it as an open circle, signifying that it's not going to work. It's not shaded in. But if I want to be less than another number, that means I need to start shading to the left because all of the numbers less will be behind us, or in other words, shading to the left. Alright, now it's time to get to what all of our new information is. Because you're never going to be given an inequality that is just plain and bare bones, x inequality something. There's going to be some more algebra going on. Like what if we had x plus 3 greater than 9? Or what if we had x minus 4 greater than 10? We're going to have to understand how we can work with these and how are we supposed to graph them. Well, the good news is that we can use the same rules that we use for solving inequalities. We can simplify it with our use of inverse operations. Inverse operations. And so what we're looking to do is we're looking to make our x all alone on one side of the inequality by applying the inverse operation to what we see. So for instance here, x plus 3, I could get rid of this plus 3 by applying a minus 3 to both sides of my inequality, leaving me instead with x greater than 6. Well, that's nice because now we know how this graph is going to look. I know that my important point is 6, and I know that since there's no bar underneath, no or equals to, we need an open circle. It's not allowed. And greater means that we're to the right of our number, so I'm going to shade just to the right of 6. Now again, you guys know it doesn't matter if x is on the left or if x is on the right. That just means that's where our attention should be focused. So here, I see my x on the right, but there's a minus 4 accompanying our x. Let's remove that by using the inverse operation of plus 4, giving us 14 less than or equal to x. And now we have another simple inequality. We know that the point that we care most about is 14 because that's where our changes are going to happen. And my inequality is telling me x is greater than or equal to. Or equal to, so fill it in. Greater than means shade to the right. And there you have it. So if you have inequalities where there's pluses and minuses involved, you can just use the inverse operation to remove it from your variable and turn it back into the situations that we feel most comfortable with. Now I'm going to step it up in just a second. I want you guys in the next few seconds to pause the video and try and see if you can handle all of the pluses and minuses here. I'm going to be solving these two different ways, so whichever way that you feel most comfortable with, you can give that a shot. So try these out, pause the video, and I'm just going to hold on for a few seconds. Resume it when you're done. Okay, great. So right around now, you should be resuming your video, and it's time to go over these. Now, I'm sure you noticed that there's a lot more numbers here. That just means there's a lot more inverse operations that we're going to have to undo. You could do them one at a time. You could say, hey, I see this plus 14 near my x. Let's undo that with a minus 14 on both sides of the inequality. That would leave an x, and this leaves a minus 9. Now we just have to figure out what 25 minus 14 is, and that's going to give us 11. Well, we still have one more operation to deal with. We have this minus 9. We can undo that with the plus 9 on both sides. And here, now we've got the x all alone. X is less than 20. Great, now we're ready to graph it. Here is 0. If you want, you could go 10, 20, just to give yourself some perspective. And I know that I want an open circle at 20. There's no bar underneath. There's no or equals to. If x is less than 20, less means behind us, we're going to shade to the left. Now, you can attack them one at a time, or you can combine some like terms that you see on either side of the inequality. Like right here, I notice I've got a 16 and a minus 10 both on the left side of the inequality. So I can say to myself, okay, what would 16 minus 10 be? That would give us 6. So I combine those. And over there on the right side of the inequality, we also have some numbers that we can combine. I have a minus 50, a negative 50, and a plus 38. So let's see, negative 50 plus 38 means it's going to be negative, and there would be 12 negative left over. So there we go. But our x is not all alone yet. We still have this plus 6 right here. So we can take care of that with an inverse operation of minus 6, leaving us with x greater than or equal to negative 18. So again, on our graph, we want to mark the important point, which would be at negative 18. And you can go, negative 6, negative 12, negative 18, or you could just do the negative 18 and be done with it. That's fine too. Again, we just want to make sure that we understand that the numbers are in proper order. Well, we've got the bar underneath, the or equal to, so that means we're going to fill it in. It's a closed circle. X is greater than or equal to. Greater means let's shade to the right. So I hope that this was informative. I hope that now you know that we can still apply inverse operations just the same with inequalities that we could with equalities. But hold on to your seats, because multiplication and division are going to throw in some interesting changes to our solving techniques. So in general, in summary, know that when you're solving inequalities, you are allowed to add or subtract numbers and variables from both sides of the inequality. So you could say something like x plus 8 greater than 10. No, I don't want that plus 8. We'll use an inverse operation of minus 8 to go away. And that will give us an equivalent inequality, which is easier to graph. And remember, when graphing inequalities, that greater means that we're shading to the right, and less than means that we're shading to the left. So x greater than 3, that would mean plop your 3. It's an open circle because there's no bar underneath, and shade to the right. You could still use less than, x less than negative 2. So here we go, our graph, 0, negative 2, open circle again, and because x is less than, we would want to shade to the left. Thank you guys for tuning in, and I will see you later.